So the problem we chose to do was a free response problem from 2007, the particle problem.
So since you know the function is of Vt equals sine of t squared, and you also know that v derivative of t equals acceleration at t, what you want to do is find the acceleration at 3. So for this, you're going to want to use your calculator to find the derivative at 3. So what you're going to do is you're going to plug in your function. You're going to hit second calculate and scroll down to the dy over dx area and plug in 3 for there, and you should get your answer of negative 5.467 meters per second squared.
In part B, it asks us to find the total distance traveled from time 0 to time 3. And to find this, we put the inside function in the absolute value because then that will account for the total positive area under the curve. So we plug that function into our calculator with the absolute value, and we go down to the integral, and as you see, it'll all be positive, and we put in the lower limit and the upper limit, and there is our answer of 1.705.
So to find the position of the particle, you're going to want to build an integrand from 0 to 3, plug in your velocity function, dt, and then you're going to want to put that in parentheses and add the initial condition, which is 5, in order to get the true position and not just the area. So you're going to plug in your function of sine of x squared, you're going to hit second calculate, and you're going to put the area function in, which is at the very bottom of that, and you're going to use your lower limit of 0 and upper limit of 3, and add 5 to that answer to get 5.774.
Doggo.
So for part D, we're asked between the interval of time 0 to radical 5 pi, what time the particle is farthest to the right. So the first thing to recognize is that we're given a velocity function, and in order to find the points where the particle is changing direction, i.e. the farthest to the left or right, we need to find the critical numbers within the interval. So make sure you're changing the window of your calculator to between 0 and radical 5 pi, and then use your calculator to find the zeros. So there's our first zero at x at the point 1.7720. Our second zero is at the point 2.5070. Yes! Third zero is at 3.07-ish, 3.0700. And our final zero is at 3.5450. So from here we have our critical numbers, and so we want to create integral functions in order to calculate the displacement at certain points. So we're going to set up an integral between the interval of 0 to our critical numbers for our velocity function, accounting for the initial condition that at the time 0 the position of the particle is 5. And we're just going to plug these into our calculator to find which is the greatest number, as in which is farthest to the right. With this, we also need to account our endpoints of our interval. So we also need to calculate the position at the time 0 and the time radical 5 pi. will happen after all these calculations. So we have our numbers for our critical numbers, our position for critical numbers, and so now we're going to find our position for our endpoints. So at 0, we know it's equal to 5. For the last one, we set up an integral between 0 and radical 5 pi. Add 5 for our initial condition. And from here, we just see which number is the greatest as in the farthest to the right. And so we see that at the time 1.772 seconds, that the particle is positioned farthest to the right at the position 5.895. So when you're having to give your explanation for this, you're going to say that accounting for critical numbers, the value that is the greatest will designate the point that the particle is the farthest to the right. And so finding the critical points and putting them into our integral equation, accounting for the initial condition, shows that at the time 1.772 seconds, that the particle is farthest to the right at the position 5.895.
So, for the challenging concept that we decided to explain how to find the volume of the solid with the cross-sectionals. So looking at this graph, you can see that the upper function for this volume is y equals radical x, and the lower one is y equals x over 2. So you use your integrand from 0 to 4 and put in radical x minus x over 2 squared because there is no gap. Then you continue to simplify this equation and then take the antiderivative. Then using the fundamental theorem of calculus, you can take the b value and plug it into the function, and then you take the a function and you subtract that from the b, and once it is all in numerical form, that is how you can leave it. But if you simplify, then you get to the answer, which is 8/15.
God save the prom queen.